Hello Python programmers. So in this video, I'm going to show you that how you can create a Python script to recognize human face and human smile. So first of all, let's see that what will be the final output that you can expect from this video. So there you can see that this green box is recognizing my face, and there you can see these are some noises which are also recognized as faces, and this blue box when I smile is the box for recognizing my smile. Okay, so no smile, smile, no smile, smile. Okay, so this is the project that we are gonna create. Now you have to install a few things first is OpenCV, and then you have to download the harcascade for face and smile. So let's get to our browser first. So you need to go to browser, and I'll provide the link for the harcascade in the description. You can download from there, or I'll provide the link to my GitHub repository where you can download the Python program which we'll create in this video, as well as these two harcascade. Now why am I pushing more on going to my GitHub is, if you want to use this harcascade, you have to download the whole OpenCV repository, and which is very huge. Like, I don't know the exact size, but it's above 200 or 300 MB, and the XML file is only a few KBs. Okay, so I'll provide that harcascade in my GitHub repository. You can download from there. So these two harcascade we'll be needing. First is frontal face. Where is the frontal face? Yeah, this is the frontal face, and the frontal smile is this. Okay, so these two harcascade we'll be using. There you can see there are a number of harcascade on which you can create your projects on. I have created a project on the frontal face of cat. I'll provide the link for that video also. You can watch that also. So the next thing is you need to download OpenCV. So just go to command prompt and write pip install OpenCV and Python. Okay, press enter, and this package will be installed for you. Now for me, this package is already installed, so it is saying requirement already satisfied. Okay, so now let's quickly jump to our editor to write our code. Okay, so now we are into our editor. So our first task is to import the required libraries, which is CV2, OpenCV, and time, to add some time sleep between each iteration, which I'll explain you in just a second. And the second task will be to load our harcascade. So we have imported our packages. Let's create two variables for face cascade and harcascade. We'll use cv2.cascade classifier method to load our harcascade XML files. Okay. Okay, so now we have imported our packages and loaded our harcascade. Let's call our video capture function so that we can record our video from our webcam. Okay, so we have stored the picture captured from our webcam. This is why we are using 0 here. If you have a Wi-Fi cam, you can write the address of that Wi-Fi cam. I'll do one tutorial on that also, but in this video we'll be using the webcam, so we are writing 0 here. And this video capture method is capturing the photo. Now you must be thinking that, but Harshit, we want the video to be displayed, not the still pictures. So what is a video? Let me ask you first. A video is a slideshow of pictures, right? So how we can create a slideshow of pictures? By using an infinite while loop, and this is what we are going to do here. So we are capturing the photo from our webcam and then we are displaying them in a slideshow using a while loop, and then in each slideshow we are checking whether any face is present in that specific picture or not. So we are not doing anything on the video whole, but what we are doing here is we are analyzing each picture of this slideshow which appears to us as a video. Okay, so this is a while true loop. Okay, and then what we'll do is we'll write check frame, and then we are gonna read our video here. So we are reading our video from this video capture function, and then what we'll do is we'll convert this colored image into black and white image. Now you must be thinking again that why we are doing so. So what happens is feature recognition in black and white images is much accurate as compared to colored images. This is why first we are accepting the input as a colored image, and then we are converting each slide into a black and white image, recognizing whether any face is present there or not, and then returning back the colored image. Okay, so we'll create an gray image, and then we'll use our CVT color BGR to gray to convert this into grayscale. Okay, so as I have told you, we are using our color BGR to gray to convert the frame, which is a colored image, into gray image. Okay, we are using this CBT color function. Then what we'll do is we'll use our detect multiscale function to compare this grayscale with this face cascade first. Okay, so first we'll do our face recognition, and then inside the face recognition we'll do smile recognition, because obviously smile cannot exist without a face. Okay, so let's do that. Okay, so now let me explain you these three parameters first. So first of all, we are saying that from this face cascade, which was the XML file having all the features of a face, we want to detect multiscale, or to detect the features, and the features will be selected on this gray image, which is the gray version of our original colored image from our webcam. Scale factor is a very complex term, but let me try to explain you in some simple words. Now, scale factor means that how zoomed your image will be, and the level of zoom signifies the accuracy of the recognition. Okay, so as low the value of this scale factor is, now it cannot be below 1. Okay, so how close the value is to 1 says that the recognition will be very accurate. Now you must be thinking that why don't we keep it very close to 1? Now the thing is that if we take this value near to 1, what will happen is, first it will take much longer time to do the recognition, and second it can also catch some noise as a feature. Let's say that a shadow which looks like a face will also be recognized as a face, and we don't want that. We want a balance between accuracy and not too accuracy. Okay, and the min neighbor signifies the minimum amount of neighbors or the minimum neighboring features around that specific feature. Okay, now we have applied our face cascade to our gray image. Now the output that this face variable will store is 4 values. First will be the x-axis, second will be the y-axis, third will be the width, and fourth will be the height. Let me show you that what I mean here. So let's say that this is an image of a human, which is Virat Kohli. Okay, so let's say that the face starts from here where my mouse pointer is. Okay, so this is the position of x-axis and y-axis on our screen. So first parameter is x, second parameter is y, the third parameter is the width. What will be the width of the rectangle or square that we are creating? Okay, and the fourth parameter is the height. What will be the height of the rectangle that we are creating? This height. So if we know the starting x-axis and y-axis, the height and width, we can very easily draw the rectangle and say that this area is having a face. Okay, so now let me close this. Okay, and now let's get to our notebook back and start writing our code so that we can draw a box around the face. So we have four values. First is, let's say, x, y, w and h. Okay, so for x, y, w and h in faces, actually face, we'll draw a rectangle. So first let me write the code, then I'll explain you that how it works. Okay, so now let me explain you the parameters here. So we are using cv2.rectangle to create a rectangle. The first parameter is frame. So we are drawing the rectangle on the original frame variable. Now we are not using the gray because we don't want to output the gray image. We want the original colored image. Okay, then the second parameter is the x and y value, which is the starting value. Let me open the Virat Kohli face again. Okay, so this is the face. So starting x and y value. The next parameter is x plus w and y plus h. So it is simply drawing the width and height. So x plus w and y plus h. So we are drawing these two lines and hence we can complete the face. Okay, the next parameter is the color of the box. So we are following the BGR format. So first is blue, second is green and the third is red. Okay, so you can choose whatever color you want. If you want it to be red, then make this 0. Just a second, make this 0 and make this 255. Okay, so if you want it to be red, you can do this. You can make it 255. And the last parameter is the width of the rectangle, the width of the pencil used to draw the rectangle, if you want to see it this way. Okay, now we have drawn the rectangle on our face. Let's do the same thing for our smile. Now there won't be any difference while drawing the smile. Everything will be same. So the things that we have to change is, so first of all let me indent them. Okay, so we don't want this grayscale because we have already converted it to grayscale. Okay, and we don't want that. What you need to do is you need to create another variable, let's say smile. Okay, smile, and then instead of face cascade we want to use the smile cascade because we are detecting the smile here. We'll use the grayscale image only and we have to play with these two parameters. First of all, we need to change the scale factor because the smile detection needs more accuracy because my webcam sucks. Okay, for you, you may need another value here. Depends on the quality of your webcam or the distance at which you are keeping your face from the webcam. So the min neighbor will also be changed to 20. Okay, and it will also be smile. So for x, y, just a second, for x, y, w and h in our smiles, we want to draw the rectangle, and instead of red color we want our smile to be, let's say, blue color. So we'll change the first value to be 255. Okay, now let's display our image. So what we'll do is we'll use our cv2 IamShow method to show this image into a GUI. Okay, so we have used cv2.imshow to create the GUI which will display our face and smile. The first parameter is the text that will be displayed on the top of that GUI. The GUI package used is Kinta, okay? And the second parameter is that image that will be displayed. Then we are creating a key variable which will be used to exit that GUI. So let's define the condition on which that GUI will be exited. So if key is equal to order of q, we want to exit. We want to break this loop. Just a second. We want to break this loop, and at the end of this program we'll simply release our video because our program has ended and we want to stop our webcam. Okay, so we'll use this release and we'll use our cv2.destroy all windows to completely end this program. Okay, so let's save this and let's try to run this. And we are having an error, just a second, and it's a minus sign. It should be an equal to sign. Okay, so our webcam is working and we are getting an error because min neighbor. Okay, because it should be min neighbors, I guess. Yeah, it's min neighbors. Actually it should be ei, min neighbors. Let's save this and run this again. And our webcam has started and it just stopped. So let me check. So we need to make this all capital and I guess destroy. No. So this Windows is capital, this all is capital, and we are getting an error. That was actually not an error. Now let's add this which key one. Okay, so our program is working. Let me smile. So it's recognizing my face. There you can see that this red square, and it's also recognizing a smile, I guess. Yeah. Okay. No smile, smile, no smile, smile. Okay, so there you can see that this additional squares not present at the feature are the result of some noises. Like there you can see that this specs is also reading as a smile, which is the result of a noise. Okay, so this is it. This was a short video in which I have tried to explain you that how the face and smile recognition in Python OpenCV works. Okay, and this video is not over yet because I have an announcement for you. So if you are interested in OpenCV and want some more image processing videos, then you'll be happy to hear this announcement, because in the previous video we have created that cat face recognition system. In this video we have created the human face and smile recognition system. In the next video we'll see that how we can use your phone camera as an input for this program. Like you can use your phone camera and then use it for face recognition or anything, and after that we'll create somewhat a home security system. Now let me explain you what that home security system is. Let's say that you are going out for 15 days, so you set up a CCTV camera at front of your home and then start this Python script. And what this Python script will do is it will recognize all the human faces that comes in front and then compile them all into one video. Okay, now when you come after the 15-day vacation, you will see that how many people came to your house, because all the images will be stored in a folder, and you can also see the movement because this program will also create a video of all the action that face has done. Okay, then after that I have also thought of using a ESP32 webcam which will be mounted on my robot car, which I have created for my final year project. So that I will also include in this OpenCV playlist. Okay, so this is just the starting, and I hope you will enjoy this playlist. Okay, so meet you in my next video. Bye bye.